We've been learning about radian measures, and in this activity, we're going to apply our radian measures to the unit circle. The circle shown here has been divided into 4 equal angles. How many radians are in a full circle? So if we think about what we've been learning about radians, we learned that there are 2 pi radians in a full circle. So if I started here and went all the way over here, I know that this would be what we would call pi radians. And then in a full circle, we already discovered that it's 2 pi radians. So since a full circle is 2 pi radians, that means a half a circle is going to be 1 pi radians. So we want to think about how many radians are in one of these 4 angle measures. So if I think about the angle measuring from this point to this point, how many radians would that be? Well, if I know that this is 1 pi radian, I know that this is half of that amount. So I can represent this point by saying 1/2 of pi, or pi over 2. So starting at 0, this would be 1 pi over 2. This would technically be 2 pi over 2, and that would make this piece 3 pi over 2. And then really 2 pi is also the same thing as saying 4 pi over 2, which reduces down to 2 pi. So we're going to use this understanding to help us place more radian measures along our unit circle. We're going to start with this circle that's divided into 6 equal angles. How many radians do we think one of these angles would measure? So if I think about one of these angles, this one piece, how many radians would that be? Well, since I know that the full circle is 2 pi radians, and I notice that this piece is divided into 6 equal pieces, I can take 2 pi and simply divide it by 6 to figure out the size of one of these pieces. So it would be 2 pi over 6, which I know reduces down to 1/3 pi, or pi over 3. So I'm going to cut out this one piece, and I'm going to use it to figure out the radian measures all along the unit circle. So knowing that this amount represents pi over 3, I'm going to trace it. So I'm going to start by putting one side along this x-axis here. I'm going to see how big this angle is. So I notice that this angle goes all the way out here. I'm going to just trace it. So this size would be 1 pi over 3. So this point right here would be 1 pi over 3. That's how large this angle would be. And then I'm going to continue counting counterclockwise to figure out other radian measures. So this is 1 pi over 3. I'm going to just rotate it around and mark off where it lands. So this would be 2 pi over 3. It's like saying pi over 3 plus another pi over 3. So that would be 2 pi over 3. And I'm going to continue to rotate. And so this point lands right where we have our pi. And I'm going to just write 3 pi over 3. But I know that 3 pi over 3 really just reduces down to pi. So those two expressions are equivalent to each other. So 3 pi over 3, I'm going to keep on going all the way around my unit circle. So this point would be 4 pi over 3. I'm going to trace along. And then this would be 5 pi over 3. And I'm almost back around my full circle. I'm going to trace there. And then this would be 6 pi over 3. But we already know that this is 2 pi, so let's think about it. 6 pi over 3, if I were to reduce that and divide, that would give me 2 pi. So if I go back and look at my measures, we had 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and 6 pi over 3. Now I'm going to do the same thing, and I'm going to find my circle that's cut into 12 equal pieces. So this circle is cut into 12 equal pieces, and I want to know the size of one of these pieces. So how many radians would one of these pieces be? Well, if, again, we know that the whole circle is 2 pi, and if I divide that by 12 equal pieces, that will tell me how much one of these pieces would measure in radians. So 2 pi over 12, I know really reduces to 1/6 pi, or I can call that pi over 6. So now I'm going to cut one of these pieces, and I'm going to use this piece to count radian measures around the unit circle. I'm going to use a different color pen, and I'm going to use my ruler this time to help me with my lines. Okay, so let's start. So we just said that this one piece is going to be pi over 6. So let's mark where it is. And then I'm going to use my ruler to get a really straight line. Okay, so this is 1 pi over 6, and we're going to keep counting counterclockwise around the unit circle. So this point would be 2 pi over 6, but we've already named this point as pi over 3. So 2 pi over 6, it's really equivalent to 1 pi over 3 if we reduce it. So this would be pi over 6, 2 pi over 6. This would be really 3 pi over 6, which I'm noticing that that's equivalent to pi over 2, 4 pi over 6. So I'm getting some equivalent measures here. Now let's see what my next one would be. 5 pi over 6. I don't have a point there yet. So I'll go ahead and mark that point 5 pi over 6. I'm going to use my ruler to get it really nice and straight. It's my 5 pi over 6. We're back at pi, and this time it's another equivalent fraction, so 6 pi over 6. And I'm going to continue going around the entire unit circle. And then once we get right back around to our full circle, we know that we're at 2 pi, but if I wanted to write an equivalent fraction, that would really just be 12 pi over 6. I'm already noticing some patterns with my radian measures, and I'm seeing where radian measures are equivalent to each other. Let's think about what's going to happen when I have 8 equal pieces, and let's think about how many radians would be in one of these pieces. So again, we know that the full circle is 2 pi, but this time we're splitting it into 8 equal pieces. So if we do that math, 2 pi divided by 8, that really reduces to 1/4 pi, or we'll say pi over 4. So one of these pieces is pi over 4 radians. So let's cut out this piece. We will do our counts around the unit circle and see what we get. Using my pi over 4 piece, I was able to add pi over 4, 2 pi over 4, and then I added a new one for 3 pi over 4. We already had 4 pi over 4, 5 pi over 4, 6 pi over 4. We already had an equivalent measure in simplest form. 7 pi over 4, and then 8 pi over 4 will put us back at 2 pi. So now we have all of our radian values that we're going to use for our unit circle represented on this circle.